So let's think about one of these parabolas that might open sideways and just take a look. So let's graph one that is x equals 1 times y minus 3 squared plus 2. So if we graph this, because it's x equals y squared, I know that's either going to open to the right or to the left. And since this is a positive number, I know that it's going to open to the right. I just have to find the vertex point. What's inside here is going to move in the y direction. So since it's minus 3 inside the parenthesis, that means I'm going to move up 3 units. And then the 2 at the end correlates with the x, so I'm going to go 2 units over. And then my parabola is going to look something like this. We won't do a lot of these, but I just wanted to kind of make you aware of what that happens. Let me make sure maybe I didn't, you can see this. The y minus 3 means I'm going to move up 3. The plus 2 means I'm going to move over to the right. So it opens like this. You can imagine if the number here was bigger than 1, it would narrow inside like this. If this was a fraction, it would get wider like this. If this was a negative, then it would open to the left. Okay, let's talk about one. Let's do this example. If x equals negative 1/6 y squared, what is the focus point? So I want to think about what this looks like. Since it's an x equals y squared parabola, I know it's going to open to the right or to the left. And because this is a negative, I know it's going to open to the left. So I can just kind of draw a general one. It hasn't moved left or right, so it's going to open to the left, something like this. What I'm wanting to find is this focus point. I know that the p is going to be a negative number and the y number is going to be 0. So I want to change this one from x equals negative 1/6 y squared into 4px equals y squared. So you can do this a couple of different ways. What I like to do is just try to get the y squared by itself and then do a little substituting. So I'm going to get each of these equal to y squared. So here y squared equals 4px. And here to get y squared by itself, I'm going to multiply both sides by negative 6. So now I know that since y squared equals negative 6x and y squared equals 4px, they must equal each other. So now I want to get the p by itself. So I'm going to divide both sides by x and divide both sides by 4. So p equals negative 3/2. So that means I would go out here to approximately negative 1.5, 0, and that would be the focus point of this parabola. I could find these other points by making a table of values. For right now, we're just going to make a little sketch. Here's example 2. Here's the equation. X equals 3/4 y squared. And I want to try to find the focus point. So since this is positive, I know that this thing is going to open to the right. What I want to do is find the focus point. So I'm going to start by getting y squared by itself. So I'm going to multiply both sides by 4/3. And then I know that 4 times p times x equals y squared. So 4/3 x equals 4px. I'm going to divide both sides by x and divide both sides by 4. So p is 1/3. So the focus point on this one would be at 1/3, 0. It'd be, if this is 1, it'd kind of be right inside here like this. So we'll kind of talk about what happens the closer the focus point is, how wide and how narrow this parabola is. Let's do another example. Let's write an equation of a parabola that has a focus at 0, 2. So let's think about what that would look like. If it has a focus right here at 0, 2. Well, the focus is the point always on the inside of the parabola. So that means my parabola is going to go something like this. And this just happens to be a y equals x squared parabola. And so I know that I'm going to use the formula 4py equals x squared. So my focus is 2, so I'm going to have 4 times 2 times y equals x squared. So 8y equals x squared. So y equals 1/8 x squared. So when the focus point was at 2, this was a pretty wide parabola. You can see how we're just kind of manipulating the equations to make them look the way we want. If we want the focus or if we want it in standard form or vertex form.